I'm Anil Kumar, and here is a very interesting question. We are trying to find limit of trigonometric function with trigonometric exponent. Question is, limit as x approaches 0 from the right side of 1 plus sine 2x to the power of cot x. Now first, before applying L'Hopital's rule, we should check if this is indeterminate powers or indeterminate form or not. So if I substitute 0, then what I get? I get 1 plus sine 0. Sine 0, or let me write this with 0 first, and then we'll see what we get. And we get cot 0, right? Now sine 0 is 0, so we get 1. And cot 0 is infinity, so we get 1 over infinity. 1 over infinity is indeterminate power, and this can be solved using L'Hopital's rule. Now there are two methods to solve it. Whenever we have exponents, we could either go with the rule of writing this as an exponential function, or we could do with logarithmic function, natural log. I prefer this method, so we'll go with this, right? Now, let us see the steps involved in solving such question. So this expression can be written as y equals to 1 plus sine 2x to the power of cotangent x, right? Now if I take natural log on both sides, I get ln y equals to, when you take natural log, this comes as a coefficient kind of thing, right? Multiplier. So you get cot x ln 1 plus sine 2x, right? So take natural log. Now we can take limit on both the sides. So we get limit x approaches 0 from the right side for ln y equals to limit x approaches 0 from the right side. Now whenever you're trying to apply L'Hopital's rule, you will see a quotient of functions, right? So there has to be a function on the top and function in the denominator, right? So what we can do is we can write this function as ln 1 plus sine 2x divided by cot is 1 over tan x, right? So we could write this as tan x. So you get the required form. Now in this form, before applying the rule, let's check if it is indeterminate form or not. If I substitute 0 here, what do I get? I get 1 plus sine 0, right? I get ln 1 plus sine 0 over, if I substitute 0 here, I get tan 0. Now 1 plus sine 0 is 0, is ln 1 over tan 0, which is 0 over 0. Since it is 0 over 0, we can apply the L'Hopital's rule. That is, we can write this as limit x approaches 0 plus derivative of the numerator, which is ln 1 plus sine 2x over derivative of tan x, right? Now what is the derivative of this? Let's do it. We have limit x approaches 0 from the right side. Derivative of ln, natural log, is 1 over the function, which is 1 plus sine 2x, times derivative of the function, which is cos 2x times 2x. So let me write this as 2, right? So which is 2 times cos 2x. So that becomes the derivative of numerator. Derivative of denominator tan x is secant square x, right? So this is what we get as a derivative. Now if in this we substitute x as equals to 0, what do we get? Let's see that. If I substitute 0 here, then what do I get? 1 plus sine 0. Sine 0 is 1. I mean, sine 0 is 0. So 1 plus sine 0 is 1. So we get 1 here. Cos 0 is also 1. So we get 2. So if I substitute 0 here, I get 2 in the numerator. And 0 for secant square x will give me 1 square, which is 1, right? So we get 2 over 1, which is 2. So what we find here is that the limit as x approaches 0 from the right side for ln y is equal to 2, right? So we have found the limit for ln y. We need to find limit for y, not ln y, right? So this strategy helped us to simplify the solution, right, and get a part of it. Now, what is the limit of this function? To find that, y could be written as e to the power of ln y, right? So y can be written as e to the power of ln y, right? That's the property of exponential function. So if I'm saying what is the limit as x approaches 0 plus for y, we can say it is the limit as x approaches 0 plus for e to the power of ln y. Is it okay? Same thing, right? Now for us, what is y? Y is the function. So let me rewrite here, right? So I'll do it in this thing. So what we have is, we want to find limit x approaches 0 plus for the function, which is 1 plus sine 2x to the power of cotangent x. And this is equal to e to the power of limit of x approaching 0 plus for e to the power of ln y. Now, this limit, e to the power of ln y, we have already calculated as 2. So we can replace this by 2, right? So this is equal to e to the power of 2. Do you get it? So the limit of this function is e squared. So we could write this as e squared. So normally, if you get limit of ln y as some number, then limit of y will be e to the power of that number, right? Because of this rule, right? So at this stage, you could have also written this solution as limit for y, limit x approaches 0 from right side for y is e square, right? So you could have done directly also. But here is the explanation. So this part which I've discussed here is the explanation how we get e square as the answer. I hope that helps. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.